do a practical case study with you. So first, Anna will introduce LCA as an all the theoretical part of LCA, and then you will pass to a theoretical example, which you receive already an Excel sheet that will help with that exercise. But then also we will explain how CIMAPro, which is the software that we utilize here, works, and the results that we will be getting for the project. So next slide, please. So some initial remarks. This session is going to be recorded. So and the recording is for dissemination purposes for the FLASH project. Any restricted content will be edited out, and we will actually send the recording to all partners before publishing in our social media channels. And the recording will be divided in small shots or short videos corresponding to the LCA theoretical content agenda. And any information about the use cases will be recorded. So the agenda was already presented by Fatima, so I'm going to skip this to explain you about the objectives of the workshop. So the main objectives are to understand what LCA is and how it's conducted, understand the type of data needed to conduct an LCA. And this is very important because then we will have a specific use cases workshops where we will go into a deep dive on the type of data that will be needed. Then we will also explore the existing tools to conduct an LCA and gather initial insights of the use cases for the LCA within the project. And the learning outcomes are to define the objective and scope of an LCA, define what is a functional unit, develop data inventories for materials and processes, quantify the environmental impacts, interpret the results, understand why it is important to take a whole life cycle approach to calculate environmental impacts, and how to apply LCA to the use cases, for example, in what stage with the greatest impact and possible mitigation strategies. So now I will pass the word to my colleague Anna, who will do the introduction to the LCA.
So yes, thank you very much, Marielle. Hello, everyone. So yes, this first part of the session, as is been saying, is more related with the theoretical contents and explain in which consists an life cycle assessment and which is the methodology that is applied to conduct an LCA. So that is an important part to transmit to you, so you are more get more knowledge to this and can apply it easily to each use case. And yes, what is a life cycle assessment? So it's one of the industrial ecology tools that is usually worldwide and can complement other analysis or be used in a neighborhood approach. Not to substitute, but to complement information and get a more overview of the several analyses that can be applied in this scope, even in a micro scale or a macro scale analysis. So, and also it can only contain the environmental component or be used together with other approaches to have here an economic analysis also. So, for example, life cycle costing. I think that will be also the case in of FLASH project. So that is this LCA-based methodology. Sometimes is called as a process-based LCAs because it is based on each process that is related with the life cycle of a product or a system that is in study. Yes, and it can be complemented with material flow analysis, this case, economic inputs and outputs, and also life cycle activity analysis, eco-design to improve. So it has mainly two different perspectives, that is cradle to grave and cradle to gate. The cradle to grave, it gives us the perspective of the whole life cycle, and it's really important to apply to have a life cycle perspectives because we are considering all the impacts of the life cycle production of a certain product or system. So because it can have reduce the impact in some stage, or for example, the utilization phase, but the production, so other raw materials, or even the end of life can have some impacts that they will only be analyzed if they will be included in a cradle-to-grave approach. But however, the cradle-to-gate can be also very useful. For example, when we know that the products that we want to analyze or to compare will not have differences in the end of life, for example, so we know that it's easy to recycle and so on. So we have a reference value for that stage, and is normally just applied to the production line. So at the moment that the product leaves the factory, for example, that ends the analysis of a cradle-to-gate perspective. I didn't say in the beginning, but I think if you have some doubts, you can put them all together in the end of this first part of the session. I think I will not be able to see your hands up, but if just in case if you are not understanding, please interrupt me that I can repeat. Yeah. Moving on. And that's it. So a life cycle is a consecutive and interlinked stages of a product system, from the raw material acquisition or generation from natural resources to the final disposal or the end of life. And the definition of LCA according to this normative reference, that is ISO 14040, is a compilation and evaluation of the inputs, outputs, and the potential environmental impacts of a product system throughout its life cycle. And it can be a very simple linear life cycle, just the raw materials, the production, distribution, until the use and end of life. And the end of life can be only one alternative, for example, landfill or recycling. It can be split in several solutions. A part can be recovered and recycled, and the other part that is not recovered go to incineration and generate energy from that, or just landfill. So this is examples of life cycles. This is just so sorry. You can then see with more detail. You have the presentation, but yeah, these are the normative reference that we follow to apply the methodology of a life cycle assessment. But it also can complement, for example, environmental product declaration, or EPDs, can also be useful for the FLASH project if you want to, the machine that you want to develop at the end can get an environmental product declaration that can be good for certification purposes or also marketing. Other things that have to be considered is that a life cycle assessment cannot be certified because it's a relative methodology, that's it. It will be only dependent on the goal and scope that will be defined in the functional unit. So according to these definitions, the life cycle assessment can be very specific to the case study, and if you change the goal and scope or include or exclude or process that belongs to the life cycle or change the functional unit, so the results will be different. So this is due to this relative methodology. So yeah. This is also just to be aware of the terminology. So we have the flows, the input flows and the output flows. Inside the input flows, we can consider all the resources that we will need to get from the nature or the technological sphere. So consumables, chemical reagents, lubricants, and also energy inputs, electricity, natural gas, for example. And the outputs we can have the byproducts, the wastes that are produced, and also the emissions. So these are the terminology. So we have the process, the product system, the boundary. It is important. What is included or excluded from the boundary scope, and the function unit. So, and these are the form and stages that consists of a life cycle assessment. Yeah. So we start with the goal and scope definition. And here for each use case, you will see them with João and Francisco. It's decided what we want to analyze. So, for example, I know that there is a stage in our cycle that cannot be so representative, or I know from the beginning that will not have such a great impact for the distribution. In that case, it can be discarded, but in other cases, this distribution can be the focus and must be included in the analysis. So yeah, this is the stage to decide which process and the borders that have to be included in the study, and also to define the functional unit. And the functional unit can be also very simple, such as a piece, a part of a component to produce, or it can be a functionality, a surface functionality. I know that I want to achieve this surface functional, so looking at a reverse engineering process, what parameters, inputs of the process that have to be applied to reach that functionality, or also a production cycle, for example, to study durability of a certain component. It can be decided that is okay, the functional unit will be 1,000 cycles of production of this, for example, extrusion or other process. So it can be defined in that several ways. Then we go to the inventory analysis, and this is includes all the data documentation and the data collection that this part of the work for the development of the current project in Flash will need a lot of the help of the partners of each use case to help drivers in this particular stage, also the first, but because this will collect all the data inputs and outputs that are needed to characterize the system and studies. So the inputs include, as I said, so the materials, the consumables, energy consumption, and also the outputs, waste emissions, and so on. Then, whenever this inventory is built, we can pass on the modeling in the software that we are using and do the calculations and the impact assessment. So to each input and output that will be modeled, the software can calculate its representative or the weight that can contribute to several impact categories. And we get the results, and then we pass on to the interpretation. And this is the final stage of a life cycle assessment, when we can analyze and see which are the hotspot in life cycle, the hotspot stages that represent the most impact, the ones that can be improved, and where we can add to improve. So, and we have also two perspectives here that we'll see later. That is a midpoint analysis and an endpoint analysis. The midpoint is more problem-oriented, so it's several impact categories. Climate change, water consumption, human carcinogenic issues. And the endpoint is how these categories of the midpoint will impact and can do damage in the ecosystems, resources, and health, human health. So yes, that's basically that. So moving on, yes, well, that's it. So the goal and scope is in which the reasons for the study, the intended audience, the functional unit are defined, the inventory in which the data describing the system is collected and converted to a standard format to provide a description of the physical characteristics of the system of interest, the impact assessment in which the physical flows are translated into the potential environmental impacts, the interpretation in which the results are evaluated and interpreted in the context of their significance, uncertainty, and so on. And here is the an important part after the interpretation of the results, that the improvement, what can be improved. So in which the system is modified in some way to reduce or improve the observed environmental impacts that resulted. Yeah. And yes, as I said, a life cycle perspective is important. So none possible stage that can cause impact is neglected. It has an environmental focus, of course, but it can be complemented with other analysis as previous showing. It has this relative approach and functional unit, so this is important. This functional unit defines what is being studied. So all subsequent analyses are then relative to that functional unit, as all inputs and outputs in the lifecycle inventory and consequently the impact assessment profile are related to the functional unit. So this is an important point. It has an iterative approach. So within and between the phases contributes to the comprehensiveness and consistency of the study and the reported results. The transparency is also a very important aspect, and also because if you cannot have real values of some experiment, you can get the values from reference papers that reference, as long as the scope and function unit are equivalent, and is a question that everything is well documented and referenced. So, and yes, this comprehensiveness aspects that because it considers all attributes or aspects of natural environment, human health, and resources. So these three are the final also the endpoint analysis. By considering all attributes and aspects within one study in cross-media perspective, potential trade-offs can be identified and assessed. And also because when we are modeling, and for example, CIMAPRO, that software that we commonly use for this analysis, we can get a lot of impacts, environmental impact categories, so almost 20. So it's a lot of information, and we can search what is causing some or causing why that stage or that impact category is getting a higher value of impact, and we can search inside all the database and other processes that are ready. For example, in EQ event that where CIMAPRO will get a lot of inputs and outputs, and we can do that search and understand why. Also in the results that we can get, it can be in tables, graphs, and also a tree chart that explains here the percentage of which life cycle stage or process is causing the most impact. So yes. And this is scientific approach, of course. The sources of the data are important, have to be well referenced. Just basically is that. When the LCA can be useful, so it can have two purposes: for internally analysis or externally. In internally, it can be important to compare environmental impacts of different products, but with the same function, or to compare product environmental impact with a reference to a standard. Also, in here, it's mostly when sometimes these studies are applied to identify environmental most dominant phases in a product life cycle, identify and try how they can be improved for eco-design, and identify opportunities for improvement. That's it. And also help the company to define its internal strategy for sustainability, for example. And externally, it has the marketing, of course, education and information, certification, lobbying, alignment purposes. So yes, that's it. So I cannot see the hands up, but if there is any question to put now, so everyone can put the question at the end of the.
I do have a quick question, if that's okay with you, for the previous slide. Do you have a good resource of do's and don'ts in terms of advertising our work on LCA? And is this something that you will be capable of sharing with us later on?
I have to look for that.
Because we want to avoid greenwashing, right?
So yes, of course, yes. We do help companies if they have, for example, a question of, okay, this product is really now in the market and a lot of marketing, we can help, but not just in a life cycle assessment basis. We have to look for other questions, for example, what are the certification mechanisms, and if they are applied, also to be aware of the treatment, end-of-life treatment technologies that are in a moment what their limitations in the country, European level, for example, in legislation, yes, what the directives and so on says, the recommendations, but yes, it's important to, it can be applied to avoid greenwashing, is to, in this life cycle approach perspective. So yes, because it's not just the impacts of the stage, it can be the end of life cannot be that so well prepared for this moment when the product go to the market, and that's not a proper end of life. So yes, we can gather the data and show if avoid the greenwashing first. I don't know if I can move on, or there's some. Yeah. Okay. Thank you. So, and also this is an important issue when the life cycle assessment should not be used. We cannot use a life cycle assessment to compare environmental impacts of products with different functionalities or uses, and also in a different functional unit definition scope. So, and it's not a substitution for other studies. For example, environmental impact assessment that is location or geographically dependent, but can be complementary. So, because these kind of studies are really more complex and really assess the impact and not only environmental but also social, economic for a specific region. And life cycle assessments do not that, but can complement with more results of impact categories and so on. So it can be adjusted. And it's not a substitute for other types of assessments, of course, such as risk analysis, strategic assessments, but well, can help to support them, of course. And this you can spend more time when you have the presentation, access to the presentation, some life cycle assessment resources. For example, CIMA Pro is a software that we use, but we have to pay a license. OpenLCA at times it's free. For a quick analysis, you can use also reference for other databases. Some we use EcoEvent, but there are databases that are specific for some activity sector, for agriculture or other purposes. So we can then explore with more time. And yes, we are moving to the see in more detail what is included in each life cycle stages that we saw previously, that four. I know if maybe if you have some questions in this part, you can do that, and we move on. I think I can. Let's move. So yes, this is to remind the four life cycle stages, and we'll start with the goal and scope and finish. So this stage defines the purpose of the analysis, the uses of the results, the study stakeholders, and the scope, of course, and the functional unit. So whatever is inside the borders, each life cycle stage that is considered the process. So this is just a nomenclature, but yes, we can use this for a decision support or not, just to accounting purpose, and micro level, meso or macro level, and also if it will include interaction with our system or excluding. So just some definitions. So all this list is included, and it's part of the scope definition. The product system to be studied, the function of the product system, or in the case of the comparative studies, the system, functional unit, the boundaries, so the processes that are included or excluded, also foreground and background. Foreground, it will be the process after the production, background, the other that they came previous, the production of the component in studies. Allocation, if the process that instantly can produce several byproducts and so on, and we just want to focus on one, we have to know what is the allocation, for example, mass by mass or time, operation time, or also economic relevance. So we have to avoid double counting, for example. That's why allocation is important. Also defines the methodology of impact assessment, impact category selected, and subsequent interpretation to be used. the data requirements, temporal, spatial, and technological coverage, assumption that the assumptions have to be written in the initial stage of the definition of goal and scope. So, for example, we are not considering this process because we know that it represents less than 5% of the overall impact of the product system. So we can exclude it from the borders. Also, any limitation that can be found, critical reviews, and the format of the report that is required for the study. So, in summary, the scope should be sufficient, well defined to ensure that the depth and the detail of the study are compatible and sufficient to address the state's goal. And of course, the initial goal and scope definition can be revised iteratively because it's a process of going on. And if necessary, it has to adjust according to the developments of the projects, use cases, for example. You find out that that stage at the end of the day, it has some relevance, so we are going to include it. So it's in this. It requires a lot of data and document. So moving on to the second stage, we go to the inventory or the life cycle inventory analysis. In this part of the process, has a lot of work involved because of the data collection. And according to the complexity of the system in study, it can require a lot of data to be collected and analyzed, and sometimes when you cannot have the reveals or most representative ones in the FLASH, maybe more close to the end of the project, you have the final values of each case study, and now you have just some preliminary, and also the reference values that can be found in the literature review can help also in this stage. So yeah, so the inventory includes all the inputs and outputs of a life cycle process, and they must be determined in terms of material and energy. So it's everything that have to be from the nature, from raw materials, mining activities, water, so on, technological sphere, chemical reagents, compressed air, lubricants, and also the energy. And here also it's important to define or specify, if it's possible, the source of energy, if it is a mix or conventional from the grid, or 100% renewable, photovoltaic, aeolic, hydric. It's important to detail in the analysis and have more close to reality results. And also then you can, when you have this defined, you can produce a process or flow chart. So you classify the events in a product life cycle which are to be considered in the life cycle assessment, post their interrelation. So from the first life cycle stage or process to the end, and for all of this, to complete data with these inputs from the nature, technological sphere, and also the outputs, the emissions, the waste that is produced. It's also an important thing here in the inventory that is another fourth category that we can also include in modeling in SIMAPRA, the avoided products, what it is. So it can be a material, also in energy. So we know that in our production process, there are some percentage that we can avoid from the raw materials and use recycled, or also a byproduct that can be reused and enter again in the cycle of production. So we can count that. Or for example, we are producing an electronic device that can convert waste to energy, and it's important to model that energy that will be saved from the conventional production system, and is produced from this recovering way. So yes, that's an important part here in the inventory analysis. And when you have this process tree or flowchart builds, you can start to collect the relevant data for each event. the emissions from each part of the resources, everything that will be used and considered in the study. And of course, to establish the correct material and energy balances for each process stage and event. And so this is an example. Of course, we have here the resources. In the resource, we have the materials and energy. And then you can have to pay attention, because this is okay. It's a production process for some technological component, not specified, and all this has to be in function of the functional unit considered. It's not written in this example, but all this amount has to be in function of that functional unit. So yeah, but this is the example of inventory. And also, I think that it's really useful also in the database that we can use, is because according to each input and output that we model, inside of the person there already exists a complex database that has been created and updated with, for the atmospheric emissions and other emissions, that maybe you cannot get that values from what we can measure, the measure techniques. And also the literature review, but they have been built in the databases. So yeah, the data collection involves practically this. It's energy inputs, raw material inputs, the primary inputs and other physical inputs, products, co-products, wastes, emissions to air, discharge to water or soil, and other environmental aspects. And we have the data calculation, that is the validation of the raw data, relating that to the unit process and to the functional unit and the reference. The allocation is an important point to consider, because of this, that most industrial processes yield more than one product, and then recycle, intermediate, or discard product as raw materials. For example, in the apiculture, we can obtain honey or natural wax, or more industrial things, solid electrolysis, we can obtain chlorine, caustic soda, and detergent. So to avoid the double counting, we must allocate which material consumable energy was used to produce all this, considering the mass, the quantity that we can obtain of each one of them in the same process, or their relevance in the operation time, for example. That's things like that to that able to do the process of allocation. Yes, because we are talking about is how to divide the environmental impacts between each product. So yeah, as a functional unit, good allocation procedures are essential for an effective life cycle assessment study, of course. So how to proceed? Well, in the first place, if we can avoid allocation, that's great. Otherwise, we can divide the impacts over products and do the allocation. So to avoid the allocation, you can do that by splitting the process in such a way that it can be described as two separate processes that each has a single output. But when this is not possible, and it can be very often, for example, because wooden planks and sawdust are both economic outputs of a sawmill, but one cannot split the sawing process into a part that is responsible for the sawdust and one that is responsible for the planks. So, and that's it. This is an example of allocation to avoid the double counting. So use physical causality, so mass allocation or other relationships such as economic. We have here the example of mass allocation and economic allocation for these wooden planks and sawdusts. And we also have the example or the case of the end-of-life allocation, because when it is a closed loop, we have no problem. So we have two end-of-life strategies, that is landfill or recycling, and this complete 25% will enter again the production cycle. But when it is an open loop, can have some allocation problems that we have to to consider and deal with it and solve. Because, well, okay, we have the same end-of-life solutions, but what we get from the cycle or it can degrade, the quality can decrease a little bit, and we have to just to consider what we can use as a primary quality, or it can be also used in other part of the system. So we have here to split and apply this rule that is try to measure who gets the gain from these material substitutions. This is an example that I think, I don't know if in FLASH you will have to deal with this a lot. You know, I think maybe the allocation in FLASH is more related to know if okay, the component that you want to study can be produced by a machine that produces all other components, but you only want to focus on that specific, and you have to make an allocation to tell, okay, for this specific component, I will only use the machine for 40%. And all the data, materials, consumables, and energy consumption will be allocated for that 40%. So yes, basically, I think that is the most common problem in the most of the projects. So yeah. And moving on to the impact assessment. I don't know if you have any doubts. If not, anytime you can also send an email with more specific questions. We can answer them. So the impact assessment is basically the calculation of impacts, and we have several strategies to do that. We can do a midpoint or endpoint analysis. So basically, what we consider in the impact assessment is the selection of the impact categories and best available models for their quantification. So this is generally related to the selection of the environmental models used to promote the characterization of the environmental impacts. So we know that there are almost 20 impact categories. We can select the ones that have more contribution to the system in analysis. So we have the identification of the environmental interventions that contribute to a given impact category, so this classification. We also have the quantification of the environmental interventions contribution to a given impact category, the characterization. Here the characterization is first step is important because we have each impact category as a unit. For example, climate change can be kilos of CO2 equivalent, or the other consumption can be cubic meters, for example. So they are quantified. And with that quantification, for each life cycle stage or input output that we are analyzing, we can identify when these impact categories have higher or most relevant value. So that's important to identify in each life cycle stage or process. These impacts are showing a higher value of impact. And then we have the normalization of the results of the previous phase, making use of reference values. So this normalization will divide all the impact categories by same reference value. So then when we do that, we are able to directly compare the impact categories because they are all normalized. And this is important. Already know a process stage that has or can contribute the most for the impact categories, generality of them. With the normalization, we can identify which is the impact category that has the most representative value or impact for them, because currently climate change is really important to analyze and include in studies, but sometimes it's not the top of the impact category that is contributing most. So for example, can be human carcinogenic or other or eutrophication or marine or terrestrial ecotoxicity, for example. But so this gives this important step in the assessment to to know the level of relevance of each impact category. And the final, we have the aggregation, that is the different impacts to reduce the number of the impact category in the final results. So for these midpoint impact categories that are is a big list, they will, or the software will calculate and attribute according to the categorization factors and so on. We'll know that, okay, this midpoint category have this percentage of impact in the endpoint category. So how climate change can affect the ecosystems or the human health, and if it has or not a representativeness in the resources consumption. Is this kind of analysis and final results that we can get. So yes, the classification is this. So the last cycle inventory results must be assigned to impact categories. Example, we have here methane or carbon dioxide could be assigned to an impact category called climate change. But it's possible that assign emissions to more than one impact category at the same time. For example, is CO2. Sulfur oxide is simultaneously responsible for impacts in acidification as well as in human health or respiratory diseases, for example. So yes. In the categorization, once the impact categories are defined and the inventory results are assigned to the impact categories, it is necessary to define the categorization factors. So it's basically because we in the inputs we can, or in the emissions we can have also a CO2 and methane, but the contribution of the for a time scale can be yes, it's 25 times higher. So the modeling and the calculation of this conversion factor. So this means that if the characterization factor of carbon dioxide is 1, so the characterization factor of the methane is 25, and the impact category indicator result for global warming can be calculated by multiplying this inventory result with the characterization factor. That's the case. And here we have the example of the IPCC characterization factors for some greenhouse gases. And yes, this is what we have been talking a little bit. So we have the inventory and also some midpoint impact categories that will have an impact in the endpoint categories that are these three: human health, ecosystem quality, resource use, or depletion. So in midpoint, we have a problem-oriented approach, and in endpoint, we have a damage-oriented approach. And that is basically this is the logic behind. So we have global warming potential, and that can change or have a change in the radiative forcing, also in the atmospheric temperature, and the damage will be a change in living conditions, for example. So this is why the importance of these two oriented problem or damage oriented approaches. So in the problem oriented approaches, the flows are classified into environmental categories to which they contribute. The categories covered in most life cycle assessment studies are greenhouse or climate change, natural resource depletion, the ozone depletion, acidification, and so on. Yeah, so we have the human toxicity or several categories that can be included in environmental ecotoxicity, such as aquatic, marine, terrestrial. The water consumption is also important. In terms of energy, it's not directly related. It's more the source and which the impact in other categories. But you can compare between the process analysis. For an improvement, if you can get a optimization or reduction in the energy consumption. So in these methods aim at simplifying the capacity of hundreds of flows into a few environmental areas of interest. Yes. And the damage-oriented methods also start by classifying the system flows into various environmental categories, but they model each environmental category's damage to human health, ecosystem health, or to resources use. For example, this acidification example, often related to acid rain, also can cause damage to ecosystems and to buildings or monuments. So in essence, this method aims to answer the question, so why should we worry about climate change or ozone depletion? And the eco indicators are examples of damage-oriented indicators. So yes. Yeah. Moving on to normalization, basically is a procedure needed to show to what extent an impact category has a significant contribution to the overall environmental problem, and is done by dividing the impact category indicators by a normal value. So there can be different ways, but the most common procedure is to determine the impact category indicators for a region during a year and divide this result by the number of inhabitants of that area. So it has two purposes. The impact categories can contribute only a very small amount compared to other impact categories can be left out of consideration, as reducing the number of issues that need to be evaluated. Of course, it can identify the top 5, top 10 of the impact categories to analyze and to focus on, to try to improve. And the normalized results show the order of magnitude of the environmental problems generated by the product life cycle compared to the total environmental loads in Europe. This is an example because here the results are normalized, so we can compare directly these impact categories, such as greenhouse, heavy metals, carcinogenic, smog, and so on. This damage assessment approach, showing these methods, the category indicators are defined close to an endpoint to achieve an environmental relevance, and the impact category indicators that refer to the same endpoint are all defined in such a way that the unit of the indicator result is the same. So these allow the addition of the indicator results per group. And this also means that the indicator results can be presented as a set of indicators at endpoint level without any subjective weighting. So we just have to analyze 3 eco indicators instead of a multiple set of indicators that can facilitate the interpretation of the final results and the reports to be presented. Yeah, that's it. So just to here show example of the different categories of midpoint, and after the weighting, how they can be converted in 3 categories of the endpoints. So basically that. And yes, we are moving on to the last stage of the life cycle assessment. That is the interpretation of the results. And yes, basically, it has been said. These interpretation results can help to identify the significant issues based on the results of the inventory and the impact assessment phase of the life cycle assessment. According to the inventory data, the impact categories and the significant contributions of all life cycle stages and process to the results that was considered in the goal and scope definition, and also the evaluation that considers completeness, sensitivity, and consistency checks. So it's important at the end of the results that we get to check if all relevant information for the interpretation is available, the reliability of the results and conclusions, considering the uncertainty of the data, allocation methods, and calculation of category indicators, all the assumptions, methods, and data, if they are consistent with the goal and scope, and also be aware of some conclusion limitations and recommendations for future work. But basically is that with the interpretation we can identify the opportunities to improve